Okay, good. Oh, all right, y'all. So today we're about to work on the question 6 of the free response question for the 2019 AP Calculus AB exam. If you're here for the BC test, get the hell out, because no, I'm just playing. You could probably still use these, but yeah, this is the one that we're going to work on today. We're going to work on this one. It has to do with l'hôpital. I don't know how to say it, but I think I did it right. You know, it sounds French. We're going to work on the l'hôpital's rule, which has to do with limits and derivatives. This is actually not that difficult of a question. It's just a little bit tricky the way the wording is, and you have to show some proofs. So we're going to work on it today, and I hope that you guys are going to understand it a little bit better. So first we see, let me write this down so I don't have to go right back and forth because it'd be pissing me off. All right. So functions f, g, and h are twice differentiable functions with g of 2 is equal to h of 2 and it equals to 4. The line y equals 4 plus 2 over 3 multiplied by x minus 2 is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. All right, so first, we already know when we see the word tangent, we already know we're going to be talking about a derivative, right? So if y is equal to x plus 2/3 times x minus 2, right? Or yeah, y is equal to 4 plus 2/3 times x minus 2. Sorry, it's hard to like read these equations out loud. It's tangent to both the graph of g and the graph of h at x equals 2, and it wants us to find h prime of 2 here, right? So we know that the derivative of this line is going to be equal when we plug in 2 to the derivative of this equation, that's going to be equal to h prime of 2, because if the line is tangent to the graph of h at x equals 2, that means that the derivatives are equal, the slopes of the lines are equal, correct? So let's find h prime of 2 given, here we go with this goddamn paint application, y'all. I'm sorry, this is why it be taking forever. I think I'm getting a little bit better at it. And I'm thinking I'll probably post these to YouTube as well, because not a lot of people join these live. I think I just don't have enough high schoolers on my Facebook anymore. I'm an old head now. I'm far enough out of high school, and a lot of my friends didn't take AP classes. So, all right, so here's our y equation, and we know it's tangent to h of x at x is equal to 2, right? So that means the derivatives of these, yeah, so the derivative of h of x and the derivative of y will be equal at x equals 2. So let's find the derivative of y. And this is pretty easy, actually. 4 is a constant, so we take that out, right? Now we have 2/3 x minus 2. Let's use our distributive property. And here we have another constant, right? So we can ignore this as well. Let's just focus on this is the only thing we have to derive, because these two things are pretty irrelevant. And this is pretty easy. What's the, hold on, I want to tell my brother to shut the fuck up, because be quieter. All right. I'm sorry, y'all. I don't like to cuss on these because the people are actually using this, but that is so annoying. I'm telling you, our rooms are adjacent to each other, so. Okay. So this is pretty straightforward, right? We have 2/3 times x. And the derivative of 2/3 x, we just know is going to be 2/3. So y prime is equal to 2/3, which is a constant. Actually, doesn't depend on x. So we know that h prime of 2, or h prime basically, yeah, h prime of 2, since the lines are tangent at 2, their derivatives are equal to each other, will equal to 2/3. So we solved the first part of the problem. Yay. All right, let's go back here. All right, now let a be the function given by a of x is equal to 3x to the third power. A of x is equal to, sorry, I have to write this down because I don't want to go back and forth between the windows, is equal to 3x to the third power times h of x. And we want to find an expression for a prime of x, and we want to find a prime of 2, right? So let's see. A of x is equal to 3x to the third times h of x. Hold on, let me just make sure I should have went back and made sure that there was no questions for the other. Yeah, there's nobody on here, so. Yeah. So, let me go back. So, we want to find a prime of x. First, we want to find an equation, right? And we know we're going to use the product rule here because we have two expressions multiplied by one another. So first, let's take the derivative of, using the product rule, we'll take the derivative of 3x to the third, which is going to be 9x squared, right? And we use, given the product rule, now this will be our constant here, times h of x, plus, now we use 3x to the third as our constant. We don't derive that. Instead, now we derive h of x, and we write h prime of x. So this is our equation that we set up, right? But it wants us to find a prime of 2, right? And so this means we're going to plug in 2 for our values of h, or we're going to plug in 2 for our values here. So 9 times 2 squared times h of 2 plus 3 times 2 to the third power times h prime of 2. Right, and we have all of the tools we need to get a number out of here, right? Because we know from the question that h of 2 is equal to g of 2, but that's not important because they're both 4, right? H of 2 is equal to 4. And h prime of 2 we figured out in the last question. Sorry, it looks like an N, but it's an H. H prime of 2 is going to be equal to 2/3. So when we solve this, we get 9, and now times 4, times h of 2, which is 4, right? It's 4 plus 3, 2 to the third power is 8, multiplied by 2/3. We could simplify a little bit. Since this is a no calculator question, they gave you a little lop pass here for you to spike over the net because they gave you a 3 on the numerator and a 3 in the denominator. These cancel, so you don't have to deal with the fraction. This is going to just be 18, or sorry, 16. And 4 times 4 is 16, multiplied by 9. Nine times 6 is... It's been a while since I haven't use the calculator. I think it's 54. Yeah, because 9 times 7 is 63. 54, 9 plus 5 is 14. So this will be 144 and plus 16. It's going to come out to be 160. And that's going to be equal to, sorry, that is a terrible 0, is equal to a prime of 2. Yay! We solved another one. See, those two are not too bad, right? Now, I'm not going to lie to you. It gets a little hairier. Let me check if we have any questions. No. Okay. All right. All right. So now, don't look at the answers. Psych. All right, the function h satisfies h of x is equal to, let me write this down again, I'm not trying to go back and forth. All right, the function h satisfies h of x is equal to x squared minus 4 over 1 minus f of x to the third. For x cannot equal 2, it is known that the limit of h of x while x is approaching 2 can be evaluated using L'Hopital's rule. Use limit of h of x as x approaches 2 to find f of 2 and f prime of 2. Show the work that leads to your answers. Okay, so we need to first clarify a few things. Now we have to find that. We have to think that, first of all, because h of x is twice differentiable, it's continuous. I hate writing with this cursor, but okay. So what does that mean? Well, if we think about continuity, we know that for any continuous function, as the function approaches, as the limit of the function as it approaches the value c, let's say it's the function f of x, that's going to be equal to the value of f of x at c, correct? So let's keep this in mind. And we know that the function can be evaluated using L'Hopital's rule, right? So let's look at this. As x approaches 2, because that's what it wants us to look at, as x approaches 2, because it wants us to find f of 2 and f prime of 2. I'm going to say find. All right, so as the limit as x approaches 2 of h of x is equal to, as we said earlier, it's going to be, let me look at my paper, x squared minus 4 over 1 minus f of x to the third power, right? So if we plug in 2 here, right, let's just plug in 2 instead of x, then we see that this is going to equal 0, right? And knowing that this can be solved using L'Hopital's theorem, or whatever you call it, L'Hopital's rule, we know that the denominator must be equal to 0 as well, because L'Hopital's rule, any limits dealing with L'Hopital's rule will either be, they're indeterminate, so they'll be 0 over 0, infinity, negative infinity, things like that, right? So that means this will also have to be 0. So we said, and this is the reason you can make this assumption is because it states that L'Hopital's rule can solve this equation. If they hadn't said that, then this would be probably a different story. It'd be difficult. Let's set this equal to 0. Pretty straightforward, right? Because this should be, well, we have a 1 here. We want to get to 0, so f of x should equal 1. It doesn't matter that it's to the third power because 1 to the third power is also 1. So f of x, look, we could write this as the limit of f of x as x approaches 2 is equal to 1. And because we know f of x is twice differentiable and continuous, we know that f of 2 is equal to 1, right? All right. So now that we have this, we got f of 2. We also know that L'Hopital's rule states if something can be solved using L'Hopital's rule, that the limit of the quotient between two functions as it approaches, let's say limit as x approaches c, that's a y, x approaches c is equal to L, right? L'Hopital's rule states that this means that f prime, the limit of the quotient of f prime of x, so the derivative of f of x over the derivative of g, oh shit, sorry, I didn't mean to do that for it, of g of x as the limit approaches c will also be equal to L. And we don't have to prove this. We just have to know that that's what L'Hopital's rule says. We don't have to prove anything here because we only have a certain amount of time. I mean, they time you. You're going to want to get through these questions as soon as possible. So all you have to do, you can write out this assumption, but you don't have to prove why it exists because, I mean, L'Hopital already did that. We know that this is L'Hopital's rule here. And if L'Hopital's rule holds, then that means our function is, let me just make a new. So let's remember f prime of, or f2, f of 2 is equal to what? I cannot answer it right now. So now we have x squared minus 4 over 1 minus f of x to the third, limit as x approaches 2, and because it equals 4, right? Because it had already told us that this is the limit of h of x, and we know that h of x is equal to 4, and since h of x is continuous, then the limit as x approaches, or because h of 2 is equal to 4, right? We already established that earlier on. So that means when the limit of h of x as x approaches 2 has to equal 4, correct? So that means that h prime of x, so taking the derivative of this part of the quotient and this part of the quotient as x approaches 2 should also equal 4, and that means we could solve for f prime because watch what we're going to do, right? The derivative of x squared minus 4 is just going to be 2x, correct? And the derivative of 1 minus f of x to the third, well, we know that 1 is a constant, so we get rid of that. We have negative f of x to the third. We bring the third to the coefficient, so we have negative 3 times f of x And now we have it to the second power because the chain rule, right? We're going to subtract that 3 by 1 to get 2 as the exponent. And so now, oh, and also, forgot it, because it's chain rule, right? We have to also take the derivative of what's inside, which is just going to be f prime of x. That's just the chain rule, right? So we have the outer, we took the derivative of this part. We have to also take the derivative of the inner part of the function, which is just going to be f prime of x. And so now when we plug in 2, we get f of 2 squared times f prime of 2 is equal to 4. Now we know this is just going to cancel and become 4. And we know f of 2, right, is equal to 1. So this is going to cancel and become 1. And this is going to all become -3. So we have 4 over -3 times f prime of 2 is equal to 4. And we just want to solve for f prime of 2. So let's just get the f prime of 2 by itself. So let's multiply this whole equation by -3 to get rid of the -3 there. Let's get rid of the 4. So we have 1 over f prime of 2. Oops. 4's cancel out. 3, another bone there. Woohoo! Thanks, College Board. Is equal to -3. Sorry, this is getting sloppy. And now we just take 1 over f minus 2 and inverse it. So we get -1 over 3 is equal to f prime of 2. Boom. We got it. Hopefully that makes sense. Let me make sure. We back. We sure are. We are back. And better. Yeah. So let me make sure I got it right. Yes, -1 over 3. All right. And if anyone has questions, of course, you can contact me. Nobody really watches these live. I'm just I only do the live so that I can screen share. And hopefully I can find a way to upload these on YouTube. But if you have questions, you can always message me or whatever if you actually watch these on Facebook. Let me look. Okay, so for part D. All right, this looks harder than it is. It is known that g of x is less than or equal to h of x for x is more than 1 and x is less than 3. So basically x equals 2, right? Let k be a function satisfying that g of x is less than or equal to k of x, which is less than or greater or equal to h of x for 1 x x is greater than 1 and less than 3. It's so hard to read these out loud. I'm sorry. Is k continuous at x equals 2? Justify your answer. Okay, so let's look. So this is our condition that is satisfied. G of x is equal to k of x or greater than or less than or equal to k of x, and k of x is less than or equal to h of x, right? For the interval x is greater than 1 and less than 3. So basically, I mean, like, you know, this is a little bit saying a little bit more than that, but basically we're pretty much saying x is equal to 2, right? And we know that because the question already said it, that h of x and g of x both are twice differentiable functions. Are twice differentiable functions, and they at the value of 2, they equal each other. So they are continuous by definition, and at at the value of 2, x equals 2, they will both equal 4. And by definition, this means that for both functions, g and x, as the limit x approaches 2, both h of x, the limit of h of x, and the limit of g of x. This is not the ideal way to write this, so do not. This just basically means both, right? I'm not saying divided by, but I'm just trying to make a point for you guys. The limit is also equal to 4. So by definition, these are continuous. So if the limit of g of x is equal to 4 at x of 2, which is between 1 and x equals 1 and x equals 3, which is our condition here, right? Our condition here. And this equals 4. Well, it says that k of x is either going to be greater than or equal to g of x, right? But h of x is also 4. So it's not going to be greater than g of x, because then it would have to be less than h of x, and it would have to be 4, right? So by definition, this means that as the limit of k of x, or as x approaches 2, the limit of k of x also has to equal 4. Because if it was any more or any less, this condition wouldn't hold. Because it has to be greater than or equal to g of x, but it has to be less than or equal to g of x. So it would have to also equal 4, which also means, this is intuitive, that k of 2 will have to equal 4, right? Because it wouldn't make sense if the value of it was higher or lower. Which holds that since the limit of k of x as x approaches 2 is 4, and the value of k of 2 has to be 4, otherwise these conditions will not hold, k of x is continuous. I'm trying to see what the exact question was. Is continuous at x equals 2. This is just intuition, right? You know that if k of 2 is equal to anything, let's say k of 2 is equal to 3, right? Just for fun. Let's say it was equal to 3. Then we know g of x is equal to 4 and h of x is equal to 4, but if this equals 3 and the condition is that k of x is greater than or equal to g of x or less than or equal to h of x, k of x equaling 3 is not greater than or equal to g of x, so the condition doesn't hold. So k of x has to equal to 4, and by definition, because the limit of h of x, as the limit of h of x approaches x, as the limit of x approaches 2, the limit of h of x is 4, and same for g of x, then also the limit of as x approaches 2 of k of x will have to equal 4, which by definition, as we know, when the limit equals the same thing as the value of the function at the x value as x approaches the value, that means that the function is continuous, and this is called the squeeze theorem. So there you have it. This question isn't too hard. It's just you have to do a lot of proving things, but it's nice that they just give you the assumption that it can be solved with L'Hopital's rule. So yeah, there it is. Thank you for tapping in, and yeah.